Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to start a new topic of discussion which is on EMC consideration. EMC actually stands for Electromagnetic Compatibility. Okay, so this video is actually a revised one. Okay, my previous video, which is the part 1 series discussion on EMC, okay, I guess that this is probably my best video. I got quite a fair bit of reader. However, because of your valuable suggestion and also input, I have decided to revise this video so that it can capture more audience. Okay, so this video, I will discuss that EMC, Electromagnetic Compatibility, which is equals to EMI, Electromagnetic Interference, plus EMS, Electromagnetic Susceptibility. Okay, so in short, EMC is equals to EMI and also EMS. Okay, EMI sometimes is also referred as emission. EMS is actually referred as immunity. So in short, EMC is basically a combination of emission and also immunity. This will be the part 1 series discussion on EMC. So guys, if you're keen to know more about EMC, okay, please take a look on the playlist, okay, under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me through the comment. I also like to appeal to the expert. Okay, please contribute through the comment, okay, for this learning committee. Before I continue, I'd like to urge you guys to help this channel by like this video. When more you guys actually like this video, okay, this video will have a better chances to reach out to a larger audience. So guys, give me a few seconds by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Let's quickly understand the definition of EMC. This is what I have mentioned on the content page. EMC is actually equals to EMI and EMS. What is actually EMC? Okay, so EMC is basically the ability of a product, equipment, or system so as to be able to operate in a satisfactory manner and they will not overly contribute to an electromagnetic environment. So in short, EMC is basically a combination. Firstly, on the emission, they must not contribute, or maybe I should say that they should not overly contribute to the environment. They are also expected to operate in a satisfactory manner. So next, what is EMI? Electromagnetic interference. Like I mentioned earlier on, this is something like an emission. Electromagnetic energy that is emanate from one device which cause another device nearby to have degraded performance. So this is actually a simple definition of EMI, which means that the emission from one device actually cause another nearby device to downgrade in terms of performance. Next, what is EMS? Electromagnetic susceptibility. Okay, so sometimes known as immunity. It is actually the ability, okay, for a device to function properly in its intent electromagnetic environment. Tolerance in the presence of electromagnetic energy. So in short, you can see over here, this is actually a combination of these two. This is to ensure nothing overly contribute by your device to the environment. This is to ensure your robust design of your electronic device here. Passing the electromagnetic compatibility compliance test is a critical step in bringing electronic consumer product to market. Okay, so basically, in short, if you have any new product that you want to introduce to the market, you need to ensure that they actually pass the EMC test based on different region. Okay, you are actually required to satisfy those region compliance tests. EMC compliance ensure that our product operate correctly without emitting or being affected by electromagnetic interference. Okay, below is a detailed guide on EMC test standard and how to pass EMC compliant testing for electronics consumer products. So in order to understand this EMC and test standard, okay, so EMC compliant involve two key aspects. First one, which is the emission. Okay, so emission actually ensure that our device does not emit electromagnetic interference beyond permissible level, which means that they actually has a certain level. Okay, we need to ensure that any electronics device that we want to introduce to the market, they don't exceed that particular level. So this is what we call emission. Next, on immunity, okay, we need to ensure that our product is actually operate as it intend in the presence of external electromagnetic interference. For example, okay, any new product that you design, you actually work, let's say, in your room. Okay, basically in your room, you have 3G, you have 4G, you have 5G, you have Wi-Fi, you have Bluetooth. Basically, all this can be an interference. So hence, okay, your newly product must ensure that they are able to work even in this harsh environment. So basically, this is what we know as immunity. These are the common EMC test standard. Okay, so CISPR standard is actually an international standard. We have CISPR 22, CISPR 32, and CISPR 35. Okay, so basically you can see that they are actually target for different test device. This is mainly for information technology equipment, IT. Okay, basically with some emission, okay, in order for them to work. And 32 and 35 is basically the emission and also the immunity for multimedia equipment. Okay, nowadays we are going to have more and more on this multimedia equipment. As for the Europe, okay, they come out another standard, okay, which is known as EN standard. Okay, so basically these are all the EN standard. Again, they are actually the same equipment, okay, but Europe come up a different standard to ensure that any device that you want to sell in Europe, you must compliant to this EN standard. So basically, in short, they actually take a reference from the CISPR standard, they modify some of the parameters, and basically they come up their own standard. So therefore, if you plan to build your electronic product that you actually target to sell in Europe, you need to be ensure that all these tests will be compliant. Next will be FCC. FCC is for US. Mainly is FCC Part 15. Okay, so Part 15 actually cover the unintention and also the intention radiators. So basically, in short, anything that you radiate out, okay, basically will be covered by FCC Part 15. Okay, so the rest, okay, we actually under this global standard, which is the IEC 61000 series standard. Okay, so basically these are a series of tests. Okay, so later on, when you actually see my so-called playlist, you will be able to understand all this. Okay, so in terms of a specific industry, for example, for military, they actually have this mil spec 461. So basically, they have even more stringent standard, okay, for us to comply before they are able to use in an environment for military, or D0160, which is mainly for avionics equipment here. Okay, for an EMC problem to assist, okay, there must be three elements. Okay, so in order to have the issue of EMC, we must have these three elements before we have this EMC issue. The first one will be the disturbing source, okay, which means that the culprit, the one that generate the noise. The next one will be susceptible circuit, okay, which means that the victim. Last but not least, the coupling path is basically the path that link the source to the victim. Okay, so basically the path can be conduction, magnetic or electric field coupling, and also maybe far field coupling. So basically you can see from this diagram here, this is the noise source, which we call it as an interference source. It can be either magnetic or electric field. So this is what we call near field. Far field is basically electromagnetic field. This is actually the victim. Okay, so basically how does the victim will be affected? Will be basically they can be some form of disturbance. They can reduce the performance, or under extreme case, the device can be faulty and malfunction. Next will be the coupling path. You can see that how does the source actually reach the victim through the coupling path. So in short, okay, if any one of the three elements is eliminated, the EMC problem will be resolved. For example, if we can remove away the source, then we will not have any victim at all. So next, okay, if we meet our victim stronger, okay, which means that they will have a better immunity. So therefore, even with the noise, our victim will be still able to operate in a satisfactory manner. Then again, the EMC problem will be resolved. Last but not least, I think that this is the best way is how to cut the coupling path. For example, I know that the source actually come from this path, and if you imagine we can cut away this path, which means that we break this point here, then the noise source will not be able to reach the victim. Then again, with this, our EMC problem will be resolved. So basically, in short, if we can so-called remove away the source of the noise, if we can make the victim stronger, or if we can cut the path from the source to the victim, then all the EMC problem will be resolved. So in short, either one of them you remove, you actually solve the problem of EMC. Okay, so basically this is another diagram to relate what we have discussed over here. So let me just highlight the source, the victim, and the coupling path. Okay, so this is actually the victim, the source of the noise 1, and the source of noise 2. Basically, you can see from here, this guy is so-called doing a drilling. Okay, so basically you can imagine that there will be a lot of noise that generate from the drilling machine. Okay, you can see over here, they share the same power supply. So therefore, the noise actually couple over to the so-called the power supply that is used by the victim. And therefore, you actually see the line on your TV. Okay, so basically, this is also another form of EMC. Basically, the noise generated from the so-called drilling machine can come from the cable all the way reach to the electrical supply because they share the same electrical supply. So therefore, the noise couple over and then finally it reached the victim. So therefore, you actually see the line on the TV, for example, for this case here. Another possibility is basically, for example, someone make a phone call, okay, which generate a EM wave. Basically, the EM wave so-called propagate and reach the victim. For example, for this case is the TV. Then again, you will be able to see the line. And this is what we call the radiate. Okay, basically the coupling path, this is what we call radiate because the air is the medium. Over here, this is what we call conducted. Okay, because the cable or the conducted material is actually the medium to carry the source of the noise to the victim. As from this case here, the source of the noise actually propagate through the air, reach the victim. So therefore, this form we call radiate, and this form here we call this conducted. So in short, keep this in mind. Okay, so basically for EMC, there are actually two forms. One is through the air, which we call radiate. Another one is through the cable, which we call conducted. Okay, I will explain this further later on. Okay, so what will be the source of EMI? Okay, EMI, in fact, is everywhere. The source of EMI include both nature and man-made. Okay, man-made noise can be divided into intention and unintentional source. Okay, what is the key difference? Okay, intention source are those which must radiate in order to perform their function. Okay, for example, our mobile phone. Okay, our mobile phone need to radiate so-called the signal, the EM wave, then they will be able to function. Okay, without any radiation, then our phone will not be able to work, so-called work. So therefore, for phone, okay, basically this is what we call the intention source. Basically, the source of the so-called radiation or EM wave is actually intentionally, and therefore, because of this, then they were able to so-called function. So this is what we lump this as intention source. What is unintention source? Basically, these are, for example, some computer device, some switch, some appliance, tools, motor, etc., they generate unintentional release energy into the environment. So this is what we call the unintentional source. Okay, so over here you can see that some of the nature source, some of the man-made source also. Okay, so I will explain this in the playlist. So basically, if you guys are keen, okay, please see the playlist for more information. For coupling or crosstalk to occur, there must be a coupling path between the source and the susceptibility circuit. Okay, so basically this is what I have illustrated earlier on. So this is the source of the noise, this is the victim, this is the path. Okay, so this coupling path can be in this either of this form. They can be electric field or capacitive coupling. Okay, so basically this is what we call a near field. Okay, under near field, it can be either electric or magnetic field. Basically, for electric field, basically is also known as capacitive coupling. Magnetic field is also known as inductive coupling. So these two actually fall under near field. While for far field, we actually say that this is actually electromagnetic field coupling. Okay, so this is for far field. However, keep this in mind, this coupling can also via any conducted path. Okay, so basically in short, can be any cable, power source, etc. Through, like it mentioned here, any wire or even PCB trace that actually connect the source and the victim. So another way is basically for the common impedance coupling. Okay, so again, all this will be illustrated later on. Okay, to solve an EMC problem, which I have mentioned earlier on, firstly, we need to define the problem. Okay, so it always very challenging. How can we actually define the problem? For example, it is almost difficult to always identify where is the noise source. Basically, if you are able to identify where is the noise source, you build a shield, then you resolve the EMC problem. For example, for this case here, where is the interference noise source? So if we know, okay, so I don't think any big issue. If we know where is the source of the noise, we just build a shield, we just eliminate away the noise, then we solve the EMC problem. Next, okay, I think this is quite obvious. Okay, what is the sustainability circuit? Who is the victim? Okay, I guess this is quite obvious. We can actually see the effect, or you can measure the effect, or you can feel the effect. So basically, this will be much more easier, okay, to so-called identify where is the victim circuit. Next will be the path. How are the source and the sustainability circuit actually coupled? So earlier on, I mentioned that it can be electric, it can be magnetic coupling, or a EM wave coupling. So basically, you must know how does the noise source actually reach the so-called the victim. Okay, so how can we actually break the noise path? How can we actually break the coupling? Okay, so for example, okay, we can suppress the noise at the source. This is ideal. Okay, because if you can suppress the noise at the source, then you resolve all the issue of EMC. Okay, however, this is always very challenging. Okay, to suppress all the noise, okay, it almost quite difficult. So most of the time, we either trace where the path from the noise couple to the victim. I think that will be more easier. Okay, another way is we meet the victim stronger. Again, this can be very subjective. This is commonly not practiced under this EMC case here. Okay, so for example, you can buy a stronger so-called subsystem, stronger so-called design to make it more robust to the source of the noise. Next will be minimize the coupling between the source and the sustainability circuit. So basically, you can, for example, put the noise source and the victim further away. So with this, we actually minimize the coupling effect. So basically, this gives you some overview of this EMC. Okay, so this is what I have described earlier on. So EMC, in short, they can break into two parts, under the emission, second under the immunity. So again, under this part, they can be further break into radiate and conducted. Radiate means through the air, conducted means through any conducted material. Same for the immunity. Okay, again, you can break under radiate and also conducted EMS. Okay, let's take a closer look on all these four different types. Okay, so basically, radiate EMI, radiate EMS, conductor EMI, and conductor EMS. Let's just focus on the radiate EMI first. Radiate electromagnetic interference occurs when a device produces electromagnetic energy in the form of an electrical field. Okay, so this energy travels through the air and can cause unwanted effect in other devices, even if they are not in physical contact. Okay, basically when they are not physical contact under this radiate. Okay, remember, keep this in mind. This is also sometimes known as radiate emission. Okay, so basically your any new DUT function, for example, you make a new electronic product. Okay, they basically emit out some of the electromagnetic wave. This can be a disturbance with those working nearby. Okay, for example, you have some of the device that actually work nearby. Okay, the noise that is actually released by your DUT, they can actually cause interference to this device here. So hence, okay, even they are not physical contact, this can be also an issue. Where will be the source? Okay, the radiate EMI is typically caused by higher frequency current or voltage in the circuit. Okay, so which is actually because of high current, high frequency current or voltage, then they are more prone to so-called radiate out. So once they able to radiate out, they basically will be generate this electromagnetic field. Okay, so this field can radiate into the surrounding environment, and this can become a big issue. So the source may include the power supply, oscillators, switching circuit, wireless communication device, and some of the extreme case, some of the poorly shielded cables can be also the source of the disturbance. How this is going to affect the other device here? Okay, so basically the radiated EMI can actually cause an unwanted effect in other device. Okay, for example, our computer restart or the device restart, or maybe the Wi-Fi drop. Okay, so basically our device, for example, a mobile phone, okay, the connection of the Wi-Fi suddenly disappeared. Okay, this become a big issue. How this is actually spread? Radiated emission can spread outward and travel a long distance through the air as electromagnetic wave, which can affect other devices even without a physical connection, which I have explained earlier on. Next, how can this be tested? Okay, radiated emission, basically they are actually required to test between 30 megahertz to 6 gigahertz. Special equipment, okay, such as spectrum analyzer and also EMI receiver, basically they are actually used to detect and measure the radiated EMI. Measurements are often conducted in a controlled environment, okay, like this adequate chamber or even some open area test site, okay, to assess whether the device can comply with the standard. How to reduce all this so-called emission? Okay, EMI can be reduced by grounding or earthing. If not, you can also consider to use the shield cable or build a shield, okay, to enclose the noise source. So this is for radiated EMI. Okay, so the regulation and compliance, the standard and regulatory body, okay, such as the FCC in the US and the International Electrotechnical Commission (IEC) actually set the limit on the allowable EMI emission, okay, to minimize interference. Basically, in short, okay, so these are those they decide what will be the level, they will decide all the rules and regulation, then we need to comply whatever so-called rules they actually so-called set up. Mitigation techniques here. So as I mentioned, we can do some form of shielding, okay, by building some enclosure. Okay, the enclosure can serve so-called protect the sensitive device or the component in conductive material to block emitted electromagnetic wave. Filter, okay, using electronics filter to suppress high frequency signal. Proper grounding can be also another so-called key factor that we can reduce our radiated emission. Okay, so ensure good grounding practice to minimize the formation of unintended radiation group. Okay, so basically this part, okay, you actually will be heavily discussed also. PCB design, okay, we can do a proper layout. Okay, when we actually have a proper layout technique, this actually minimize the loop area. Okay, we try to put so-called the same function together so as to minimize the loop area, and therefore we can also incorporate ground planes, okay, to reduce this EMI generation. Next, okay, basically this is a very simple so-called test setup, okay, to do this radiated emission. Okay, so if you keen, okay, please see the video at so-called at the playlist under the description. Okay, so basically this is how we can actually set up to do the testing for radiated emission. Okay, let's move on into radiated immunity, okay, so which is also known as radiated EMS. Radiated electromagnetic susceptibility is a measure of how susceptible an electronics device is to external electromagnetic interference. Like I mentioned earlier on, basically under this case here, okay, we actually bombard the DUT with a lot of EM wave, and hence we see whether the DUT can be functioned and all. So here are some examples of electromagnetic interference. Okay, for example, everywhere in Singapore, for example, we have radio and TV broadcast signal. We also have a lot of wireless communication like Wi-Fi, Bluetooth, microwave source, including 5G, 4G also consider microwave source here, etc. Magnetic field from transformer, motor, and appliance also. Electrostatic discharge, lighting strike, automotive ignition noise, basically when you start your vehicle, electric power line disturbance. So basically these are some possible example of electromagnetic interference. Okay, basically these are undesired case, but sometimes we can't simply remove all this so-called noise source. Basically, we need to ensure that our device is able to operate in this kind of so-called stringent environment. Next, okay, what is the key purpose of doing this radiate EMS, radiate immunity? Okay, firstly is we need to ensure that the device that we build, they can actually withstand the exposure to electromagnetic field from other device, radio transmitter, or environment source, okay, to minimize perform degradation, malfunction, or safety risk. Basically, in short, okay, we need to ensure our device is still able to function normally. Okay, so the key thing is we do not want to have any performance degradation, malfunction, or even as some case, okay, basically safety become a key factor. Testing, okay, how can we do the testing? Radiate radiate EMS test actually involve expose the DUT to control electromagnetic field of specific strength, frequency, and modulation. Testing typically follows standard like IEC 61000-4-3, okay, which describe the methodology for immunity testing. So basically, in short, again, you can always see the videos, okay, under the description for all this discussion. Next, in terms of the relevant, okay, so basically why we need to do all these tests, okay, this can be very crucial for industry such as automotive, aerospace, telecommunication, and also consumer electronics product. Okay, this is very important for device that use in environment, okay, with high EM activity such as near radio transmitter or industry equipment. Okay, for example, let's say we fly a aircraft. Okay, although we are strongly so-called discouraged to use our mobile phone, but end of the day, we may not be able to prevent everybody from using the satellite so-called mobile phone, for example. This can become a big issue if we don't do this radiate immunity test. So therefore, this form of test, radiate immunity, can ensure that basically for example, when we actually on board on the aircraft, any form of this EM wave will still meet the flight so-called safe. Basically, this is why we need to do this radiate immunity test. The parameters in testing, the frequency range, okay, the frequency range to do this test typically 1G or maybe up to 6G. Okay, nowadays the standard is up to 6G. Okay, the frequency to start will be from 80 megahertz. The field strength, okay, there are a few field strength, 3 volt per meter, 10 volt per meter. Depend on your duty, then we will decide on the field strength. Modulation, the type of signal modulation applied, okay, such as AM, FM, or pulse modulation. Okay, so basically, mainly we will be focusing on the AM, okay, for this video here. Okay, so basically, again, all this I will describe later on the so-called later on the few video over here. Okay, so again, this is a test and measurement setup for radiate immunity test. Okay, so over here you can see that this is basically where your DUT, okay, this is where your antenna, you generate your so-called your noise source, okay, from the amplifier. Okay, so I keep this simple. Okay, so basically let's move on. Okay, let's move on to conductor EMI. Conductor electromagnetic interference refers to the unwanted electromagnetic energy that is transferred through electrical conductor such as power line and cable. This interference can affect the normal operation of electrical and electronics equipment, causing degradation in performance, malfunction, or even complete failure. Okay, so basically this is a definite so-called a definition of conductor EMI. So basically you can see that the noise actually come through the electrical conductor, okay, whether is it the power line or any so-called cable that support the device, for example, here. Okay, so where will be the pathway? The conductor EMI typically travel along conductive path like power line, signal cable, or ground connection. It can be caused by device or system that is actually generate this unwanted EM signal that actually travel this conductor. The source of conductor EMI. So the power supply, the switching regulator, the electrical motor are common source of conductor emission. Devices such as computer, TV, and communication equipment can also produce conductor EMI, okay, if they are not properly shielded or filtered. Next, okay, on the effect on equipment, Conductor EMI can actually lead to malfunction or degradation of performance in sensitive equipment. Like, for example, medical device, we could not afford the medical device to be filled. So therefore, this is very crucial. And also for our communication system or industry machinery, which rely on precision and stable electrical signal. Okay, so basically for this case here, as I mentioned, the noise source actually enter through the power or through the communication signal, etc. So basically, we need to ensure. So for example, for the medical device, let's say it enter through the power supply. Okay, the power supply become so-called not stable, and this can be an issue because the medical device can be reset, and this can be a so-called catastrophic effect here. So some of the controlling method, filtering, okay, component like filter, capacitor, inductor, and RC filter, okay, basically they can be used to block or reduce the transmission of EMI. Shielding, okay, conductive shielding in cables and device can also prevent EMI from escaping or entering through conductive pathway. Grounding, okay, proper grounding technique can help disperse the unwanted electrical noise. Okay, so basically this is for the conductor EMI, and you can see the test setup for the conductor EMI. Okay, let's quickly move to the last one, okay, which is the conductor EMS, conductor immunity. Okay, conductor electromagnetic susceptibility actually refer to the ability of an electronic device or system to withstand electromagnetic interference that is transmitted through its cable, wire, or conductor. Okay, so basically, in short, for this case here, we actually inject the noise through the cable, through the wire, or through any conductor material that is actually connected to the DUT. Where will be the source? Common source of conductor EMI actually include the nearby electronics, power supply, radio transmitter, and electrical equipment that generate these kinds of fluctuating electromagnetic field. Okay, this can disrupt the performance of sensitive device when high frequency noise actually enter through the conductive connection like power cable or data lines. Test and standard, okay, devices are often subject to conductor EMS tests to ensure that they actually meet regulatory standard like those defined by the International Electrotechnical Commission, IEC, the Europe, and other governing monitoring. Okay, so basically this standard actually help to ensure that equipment can either reject or tolerate external electromagnetic disturbance transmit through conductors. Okay, so come to the last slide. Okay, basically before the so-called test setup. Okay, what will be the mitigation techniques? Firstly will be by the filtering. Okay, so we can build the simple LC to block the high frequency noise from entering or exit through conductor. Shielding. Okay, so shielding material around the cable. For example, we shield the cable or device that can help to contain or redirect the electromagnetic energy. Proper grounding, okay, we need to ensure a good grounding system that can help to dissipate unwanted electromagnetic energy. Last but not least, on the twist pair cable here, okay, so this can reduce the potential for EMI by cancelling out the induced noise. Okay, so basically you can see how we actually can do conductor immunity, okay, through the CDN or through the clamp. Okay, so you can see the playlist. Okay, basically I will explain how can we actually do this conductor immunity, okay, through the CDN or through the clamp. So with this will be my last slide. Okay, so to do a quick conclusion, EMC is actually equals to EMI plus EMS. So for EMI, basically it can be radiated EMI or conductor EMI. For so-called the immunity, again, it can be under the radiated immunity or conductor immunity. So basically, you can see that this is basically your DUT actually release the source of the noise. So basically, this form here, this is what we call the radiate source. Okay, so basically they radiate up the electromagnetic wave. Okay, so basically this is what we call the radiate EMI. For example, okay, basically this is your DUT, okay, and this is the power socket. Basically, you can see that the DUT can also release a electromagnetic wave through the power cable. So therefore, this case here, we call this as conductor EMI. Okay, so for this case here, okay, under the immunity, okay, so you can see that there are actually two forms here. So basically, this is how we inject our noise source. We inject our noise source through the radiated EMS, okay, again, we see whether our DUT can still function in a satisfactory manner. If not, we can also inject our noise onto the cable, and basically the cable will bring the noise source to our DUT, and again, we can monitor whether our EUT can still function or not. Okay, so with this, I'd like to end my discussion. Okay, again, I'd like to highlight, okay, to help this channel by like this video and subscribe. Once again, thank you so much. I hope to see you guys soon. Bye for now. Thank you.